TV off. TV on. On we go. Come on. Let's go. Hello. There we go. Whoops. Right. Next lesson's nice and easy for you. Something you might already know about states of matter. Got that? Have you done this in chemistry? Done this in chemistry? No. Have you studied it before? Do you know this state of matter? Yeah. Yeah, there's particles that come into it now. Right. So, water. What we're going to look at now is the different ways matter could be, different forms it could be in. So we all understand that some things are solid, some things are liquid, some things are gas, you know. And why are some things solid, some things liquid, and some things gas? So we imagine at the, you know this from chemistry, at the very small scale, the materials are made up of atoms and molecules. But you know, this is basic chemistry. I'm not telling you anything new here. So as you know from science, things are made of atoms. I mean, a 10-year-old knows this, right? It's not new information. These atoms come together to form molecules. You know molecules from chemistry. What's the molecule for water? H2O, isn't it? Now, what exactly is a molecule? So in chemistry, what do you define as a molecule? Yeah, but a little bit more than just that. Yeah, group of, but there should be one extra piece of information. Well, maybe not. I'll tell you, for me, a molecule is an electrically neutral group of two or more atoms held together by chemical bonds, and the famous example is H2O. I don't know, is this the case in chemistry? Is Lorraine particular about it having no charge? I like to say it has no charge, because if it has a charge, then we call it an ion, you know. Anyways, it's not really a big deal. It's two or more atoms held together by a bond. And you probably have studied the different types of bonds in chemistry. You have, hang on, let me see, valence, is that one of them? Covalence? Covalent bonds. What else have we got? Metallic? Metallic bond, ionic bond. There's four you do, isn't there? Or huh? The heck is that one? Okay. Yeah, we don't we don't study the types of bonds in physics. We just say that there is a bond. Can you get this definition, please? What did you say the last one was called? Dative. That's a new one for me. I've not heard of that one. Ah. Yes, Roger. Is covalent when it shares an electron? Is that covalent? And what's ionic? A transfer of an electron. Aha. And what was the other one we said? What's the other one? Metallic. What's that one? Yeah, but how is what's the force
of attraction between the localized electron and
so in the sea of electrons, that's the delocalized electrons in the metal, that attaches to something with okay. I suppose Yeah, I suppose we're not too worried about the different types in physics at all. Okay, do you have this? Yeah, you got this? We'll talk more about atoms in the next semester though. So for example, what does water look like at the molecular level when it's frozen solid as ice? Or if it's a liquid? Or if it's a gas? What does the water look like? So look, here's a little picture. Now just before you draw this, I just want to explain it here. This is what the H2O looks like when it's in ice. So what do you notice about it? Like if you were to describe the structure, what does it look like? Especially when you compare it to the other forms. So it's more rigid. It's more like locked into place. But what about in the liquid form? How would you describe the difference here? Well, can you see that it's more dense? So, you know, this is, what did we say ice was? 950, was it? Like this. And this is 1,000 kilograms per meter cube. So you can actually see that it's more packed together. Now, this one here, it's locked into place. This one here, they're not locked, but they're touching. So they're like moving around like this. They're always touching, but they're always moving. Okay? And then in gas form, they're free. And maybe they bump into each other, but that's about it. Okay? When we go from ice to water, liquid water, we call that melting. Okay. When we go from water to gas, we call that evaporation. So when it becomes steam, evaporate. When it goes from gas to liquid, that's called condensation. So that's when it's a gas and then it becomes a liquid. It's condensation. And then when it goes from liquid to solid, what's that? So think you have a glass of water and it becomes ice, we call that freezing. Okay? So these are the three different states. If you want to go from ice to liquid water, you have to add energy. If you want to go from liquid water to gas, you have to add more energy. And this makes sense, you know. If I have water and I want to change it into steam, I have to give it some heat energy. Okay? Now, if I want to go from gas to liquid, I have to remove energy. And if I want to go from liquid to ice, I have to remove energy. This is what your freezer does at home. When you put water into the fridge actually takes energy out. Now, does anybody know where it puts that energy it takes out of the water? You know, you put some water in the fridge, it turns to ice. Because the fridge took energy out of the water. But it didn't destroy the energy, so where did this energy go? Where? Where did it go? Correct. You're right. Behind the fridge. So, at the back of the fridge, at the bottom, it's very, very hot. You know, yeah. That's where it goes. So it takes the energy out of the liquid water and puts it out the back door, and then the water turns into ice. You know. So I need you to copy this into your notebook, but I need all the words, the whole picture. Okay. Everything. Make it beautiful. you didn't draw this already, did you? Show me your picture.
Do we need to draw the atoms?
Everything, everything. And remember I said make it beautiful. You're finished, Siba? Show me your beautiful picture.
It's beautiful.
It's alright. Now you see, Siba, Chow was using a ruler. Did you use a ruler? Got it. Let's see your beautiful picture. The heck? You got it, Kim? Show us. No comment. I think Chow is the only one trying to draw a nice picture. I'll just give you one more minute, Chow. Did you write all the words down?
Yep.
Yeah, okay, good. I'll get that. Right. Let's continue. I can continue, Joe?
Yep.
Okay, so some definitions now. These definitions are quite big. You don't need to write everything, okay? So in a solid, the position of the atoms are fixed, like in the ice. No, wait, don't write yet, because first I need to read it and tell you how much to write, okay? So just process. The atoms are fixed. That is due to the friction between the molecules. So it's almost like they're locked by some friction force. It's provided by metallic, covalent, or ionic bonds. Now, you don't even have to say that in physics, because that's chemistry terms. You don't need that in the exam. Only solids can be pushed by a force without changing the shape. Again, you don't need to say that in the definition. You know, if you have a solid and you push it, its shape doesn't change. Okay? And so they can be resistant to deformation, which means change of shape. So I think all you really need here, solids are generally denser than liquids. Solids become gas. Okay. I think you just need, for the exam, the first 2 sentences. That's enough. Just the first 2 sentences. Okay. Have you done anything like this in chemistry, solids, liquid and gas, or does it come up much? Or? Are you okay, Kim? You're very giddy. What's wrong with you? Do you have breakfast? Oh, I think I know what's wrong. Too much sugar. How many cookies have you eaten? Just two. Just two big cookies. Okay, do we have the first two sentences? Yeah. Yeah? Yeah. What part are you writing, Chow?
S.
S?
Molecules.
Oh, okay, molecule. That's it. Just the first two sentences. Okay. What's wrong with you, Kim? Are you okay? Are you sure? Okay. Are you telling her jokes
No,
or?
I don't know, I'm laughing.
You're not telling her anything funny?
No.
Are you sure? Alright, okay.
The thing is, she has took ibuprofen plus.
She has what?
Ibuprofen plus.
Right. Now, before I give you the definition, does anyone want to describe how the liquid is different to the solid? So in the solid definition we said that the atoms are fixed relative to each other, and this is due to the friction force. Okay? What might we say the liquid is? How is that different?
Atoms are loose.
Yeah. They're kind of loose. And what else? Are they fixed? No. They're moving, but they're very... And they take up the container, they occupy the volume of the container, yeah. So in a liquid, the molecules are attracted to other molecules strong enough to keep them in contact. So do you remember, I was saying that they move, but they always stay in contact. But they're not strong enough to fix. So the force keeps them touching, but doesn't keep them fixed. So it just keeps them in contact as they move, but not fixed together. The molecules can continually move. Right, that's enough to write down. So just write that down.
All of them?
All of that. You guys have this? Yeah? Yeah. Up the front. Okay. Continue. Right, what might we say? So, you mentioned, Andek, about them occupying the volumes they're in and so on. And what happens if you apply a force? Does it keep its shape to a liquid? No. Right, what about gas? What's different about the gas compared to the other two? What might we say?
Yeah. Free.
They're free, aren't they? Yeah. So the chemical bond is not strong enough to keep them together. So they're basically a collection of independent, unbonded molecules which interact mainly by collision. So there's no bond, they're unbonded, And their only interaction is the collisions. And that's all. Okay. Yeah, you can write this down. You got this, yeah? Yeah? Yeah. Some ice is taken out of the freezer and placed on a table. How does the ice change over time? So, little description question. You place the ice on the table, what happens? Firstly, it gains energy. Where does it get the energy from? The sunlight. Yeah. So what happens is the molecules are fixed together, but they get more energy. So then what happens to the bonds? They break, or at least they become weaker. So they're no longer fixed in position, and now they start to move. So now what state is it? It's liquid. Now it gets more energy from the sunlight, and what happens now to the bonds?
Breaks.
Now the bonds break. So now it's the gas. Okay. So it's just to describe what happens over time. So you said you liked the conservation of energy homework. I think you said that. So you'll like this one too, because it's just a description lesson. Before you start the questions, how many states of matter did we study today? 3. Solid, liquid, gas. Are there only 3 or are there more? Who knows this? There's actually more. Does anyone know any of the others? There's one after gas. I think you do know it. No?
Vacuum.
No, vacuum's not a state. Vacuum is nothing. I think you know. Because vapor's just gas. Solid, liquid, gas. There's one after gas. I'm sure somebody knows, because I'm going to say it, and you're going to say, oh yeah.
It's with ground.
No.
No.
I'll tell you. So, if you heat a solid up, it becomes a liquid. You heat the liquid up, it becomes a gas. You heat the gas up, and it becomes... Plasma.
What?
Plasma.
Plasma.
You not heard of this?
Yeah.
Plasma TV is true. Well, no, I tell you, you know something that's plasma. The sun is plasma. Okay? The sun is not solid, it's not liquid, and it's not gas. It's a plasma. Yeah?
Not solid?
It's not solid, it's not liquid, it's not gas, it's plasma.
The whole time?
Yeah. Because it's not quite gas, because if it's gas, then, you know, it's spread out.
Why
You
is
know.
it not solid?
Well, it couldn't be solid because it's too hot. Because if you put anything solid, it would instantly melt into liquid.
What if the bond is just crystal?
No, it's possible. Like, could there be material so the bonds are so strong it would stay solid in the sun?
Why?
I don't think so. I don't think there could be a material that strong.
And so what is plasma?
It's the state after gas.
Like,
Like how would the
anything that's not solid,
molecules?
liquid, or gas?
Say again?
Anything that's not solid, liquid, or gaseous form?
No, because there's another state too. Yeah. Plasma?
Then how do you describe it?
Haven't a clue. I'll have to look it up. I just know it's the state after gas. I would imagine it must look very strange because it's very high energy, so all the molecules are moving around very fast. But the sun obviously keeps its shape, so I'll have to look at a picture. I don't know. No, you've heard of plasma or not? No. No, is this a new word? Yeah.
Another plasma.
Huh?
Another plasma.
Well, yeah, well, I mean, you have plasma TV, and you also have plasma in your blood, but these are different types. Plasma state is the same as the sun. So it's kind of a weird mixture of solid, liquid, gas. Like it's like a liquid because the sun is moving around like a liquid. It's like a solid because it holds its shape, but you can't stand on it. It's like a gas because it can spread out, but it's not quite solid, liquid, or gas. It's a state after this. It's called plasma.
Gases that are held together.
Yeah, in a liquid solid form. You can look it up. And there's a state before solid. So there's solid, liquid, gas, and after gas is plasma. But before solid, there's another state. So if you didn't know plasma, you definitely won't know this. But anyways, my point is, there's not just three, okay? There's at least 5. There's one before and one after as well. It's just you never see it, because to be in plasma, you have to be really, 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 really in a hot room, hot environment. So you'll never see plasma. And to be before solid, you have to be really, really, really cold. And when I mean really cold, I mean like 1 degree Kelvin. That's what I mean. So that's why our experience is only solid, liquid, gas, because these are the ranges we live in. We never see the other two.
And what's the state below?
It's called Bose-Einstein state, Bose-Einstein condensate state. It's a state that doesn't occur in nature because it's not cold enough. It's an artificial. You have to do it artificially in a lab. It's not a natural state.
And was it done?
It was done a few years ago. Yeah. Plasma is a natural state because the sun is plasma. Yeah. Okay, so I'd like you to try these questions now. They're mostly just description, I think. Yeah.